What are the standards and regulations for uranium exposure? Taking a look at the Agency for Toxic Substances and Disease Registry, well, we can see here that uranium exposures are limited on the basis of both chemical and radiological toxicities in occupational settings, and the Occupational Safety and Health Act regulates the limits of workers' exposure based on the solubility of uranium compound. The Department of Energy, the DOE, has issued regulations applicable to its facilities that limit environmental discharges and worker exposure to uranium isotopes. The Nuclear Regulatory Commission, the NRC, has also established standards and provisions for the non-DOE, Department of Energy, environmental discharges and workers exposed to uranium isotopes. So what do they find with OSHA? OSHA establishes that permissional exposure level, or PEL, for airborne insoluble uranium in a workplace is 0.25 milligram cubic meter. Time weighted average, TWA, is an average exposure by 8-hour work shift of a 40-hour work week, and the PEL is the TWA concentration to which it is believed that nearly all workers may be given repeatedly exposed day after day without adverse effect. Put another way, an employee's exposure given to a substance in an 8-hour work week of a 40-hour work week shall not exceed the 8-hour TWA limit given for that substance, and the current limit was set based upon the early animal study results. Uranium is primarily an alpha emitter, and workers exposed to various alpha-emitting uranium compounds protect themselves by wearing anti-contamination clothing, eye protection, and respirators when appropriate. And these protective barriers are designed to eliminate external alpha radiation exposure, for such barriers easily block alpha radiation. And the OSHA PEL for airborne soluble uranium is 0.5 mg, and this is lower because soluble uranium compounds are absorbed to a greater extent by the body. For the same exposure, soluble uranium compounds are more likely to cause chemical effects than insoluble uranium. For more information, you can check the PEL. And the NCR and DOE limit external radiation to expose 5 REM per year, and this is applicable to all sources combined. Less background, and the REM, radiogenic equivalent man, is the unit of dose actually absorbed, taking biological effects into account. There's also the environmental standards, and the EPA has established a maximum containment level for uranium 30 micrograms per liter in drinking water. And the MCL is the maximum permissible level of a contaminant in water that is delivered to any user or public water system. The EPA finalized the MCL for uranium at 30 grams per liter in December 2000, or parts per billion. And before this time, the EPA did not have a limit specific to uranium drinking water, and instead regulated uranium content through gross alpha and gross beta limits, and the EPA's rule became effective in 2003. They also established the reportable quantity accidental release standard, which requires the accidental uranium waste releasing and 0.1 curies of radioactive to be cleaned up. And in addition, the EPA issued 2 standards for controlling uranium mill tailing hazards in 1983 and amended this in 1993. And they provide for the cleanup and disposal of mill tailings at abandoned sites and at licensed sites after operations cease. And here are the key points here for the PEL insoluble uranium in the workplace, the soluble, the uranium in drinking water, and also the releases of uranium and the cleanup, the information here. So that's some background on the standards and regulation for uranium exposure. The issue is it's still a problem in a lot of places. Now that we understand it, there's a good reason to test your water and make sure there's not high levels of uranium in it.